After understanding how to visualize one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays, we would like to discuss in more details about two-dimensional arrays as a special case for multi-dimensional arrays. For two-dimensional arrays, we have already mentioned that it has exactly two indices and can be displayed on paper as a two-dimensional table, similar to this table, that it has number of rows and it has number of columns. Also, we mentioned that it can be thought of as having rows and columns. The first index represents the number of rows and the second index represents the number of columns. Now, when we say that a two-dimensional array is an array of arrays, what does that mean? It means that each row is in fact a one-dimensional array. So in this example, row 0 is pointing to an array of size 4, that it has index 0, 1, 2, and 3. And row 1 is pointing to another array, that of size 4 also, and it has index 0, 1, 2, and 3. So suppose that this table is for an array called A. So the dimension of this array is 4 by 4. So the first dimension specifies the array, and the second dimension specifies the index inside this array. And this is how we visualize the situation. That when you write the name of the array and specify only the first index, then we are referring to an array, and the second dimension will specify the index in this array. So A0 is the first array, which is row number 0, and A1 is the second array, which is row number 1, and A2 is the third array, which is row number 2, and finally A3 is the fourth array, which is row 3. As an example, if you say A2, 3, so you are referring to array 2 and index 3, so 0, 1, 2, 3, so we are referring to this element. So this is how we visualize two-dimensional arrays, is that the first dimension specifies an array and the second dimension specifies the index of this array. To declare two-dimensional arrays, it requires two sets of brackets and two sized declarations. The first one is for the number of rows and the second one is for the number of columns. And this is syntactically how to define a two-dimensional array. The two sets of brackets indicate that we are declaring a two-dimensional array. The first dimension specifies the number of rows and the second dimension specifies the number of columns. The two sets of brackets and the data type indicate that the scores variable will reference a two-dimensional array. As we mentioned before, that arrays were objects, and this is similar to two-dimensional arrays. When you declare an array of two-dimensional arrays, the name in fact is a reference to this two-dimensional arrays. And finally, notice that each size declarator is enclosed in its own set of brackets. This is not like other programming languages. They use only opening and closing brackets, and the dimensions between these brackets are separated by commas. So it's not allowed to say double, open, square bracket, 3, 4. You have to put the declarator, the size declarator, in its own set of brackets. So this is how to declare the two-dimensional arrays. The next question is how to access their elements. You know that for processing two-dimensional arrays, you need two subscripts. The first one is for the row number, and the second one is for the column number. When we say subscripts, it means indices. We have two dimensions, so the first dimension will represent the row number, and the second dimension represents the column number. If we go back to our scores variable, which was an array of size 3 by 4, 3 rows, 4 columns, now how to access its elements? First, you write the name of the array, followed by the row number, followed by the column number. So when you specify only the row number, for example, score 0, then you are referring to the whole row as a single dimensional array. The second index will represent the index inside this array. So when you say, for example, scores 1 and 2, so you are referring to row 1, column 2, so we are referring to this element. So the name of the array itself is a pointer to a two-dimensional array, and when you specify the first dimension only, then it's a pointer to a one-dimensional array, and when you specify the second dimension of the array, then you are referring to an element inside this two-dimensional array, which you can treat it as an ordinary variable of the array base type. So as an example, if we want to store 95 into row 2, column 1, so we have to use both subscripts for the row and column at the same time. So you write the name of the array, followed by the row number, which is 2, followed by the column number, which is 1, and then you put the value 95 using assignment statement. Notice how each dimension has its own square brackets. So you don't put comma between them because you will have syntax error. Our next discussion is how to use the length instance variable on two-dimensional arrays. If you remember that for one-dimensional array, dot length specifies the capacity of the array. Now, if we have two-dimensional arrays, we have already mentioned that it is an array of one-dimensional arrays. So each row is in fact of one-dimensional arrays. Therefore, if you use the length field of the array itself, it will give you the number of rows in the array. And since each row is in fact a one-dimensional array, then each row has a length constant that will tell you how many columns in that row. To illustrate graphically how two-dimensional arrays are arrays of one-dimensional arrays, consider the following example. In this example, we have a two-dimensional array of integers. The number of rows is 3 and number of columns is equal to 4. To illustrate to you how to find number of rows 3 and number of columns 4 using the instance variable length, consider the following illustration. Notice that the first dimension is in fact an array of 3 elements, and each index variable in this array is pointing to another one-dimensional array of size 4. So when you use dot length on the name of the array, it will give you the number of elements in the first array, which is the first dimension. So it will be equal to 3. So therefore, if you want to know the number of rows, simply use dot length on the name of the array. Now, since each index variable of the first array is pointing to another one-dimensional array, so when we use dot length on this one-dimensional array, it will give us the number of elements in this array, which represents the number of columns. So therefore, if you use dot length on any of these index variables of the first array, it will give you the number of columns. In summary, for any two-dimensional array, if you want to know the number of rows, simply use dot length on the name of the array. And if you want to know the number of columns, simply use dot length on any of the index variables of the first array. Finally, since two-dimensional arrays are arrays of one-dimensional array, and each index variable of the first array is pointing to another array, so it is not guaranteed that each index variables of the first array are pointing to a one-dimensional array of the same size. Therefore, each row can have a different number of columns, and we will have an example of such two-dimensional arrays, which are called ragged arrays. Now, if you define a two-dimensional array similar to our example here, each of these index variables are pointing to a one-dimensional array of the same size. So it doesn't matter if you use dot length on the first index variable, or use dot length on the second index variable, or dot length on the third index variable, all of them will give you the same number of columns. However, if we have a ragged arrays, then dot length on each index variable of the first array will give you different answers.